Okay, we're going to get started with section 1.6, part 1. We're forming operations with complex numbers. And we're going to kind of preface this with, sometimes as a kid, we learn things that our parents didn't quite tell us the truth when we were little until we got older. And this is one of those things. So remember when you learned the square root? Remember, up until this point, we've known we can take a square root of a positive number, we can take a square root of a 0. But up until this point, if you saw a square root of a negative, you couldn't do it, or so you were told. So today we're going to learn that you can take the square root of a negative number. And the square root of a -1 is something that we call the letter or the number I. And we call the number I the imaginary number. So from now on, when you take the square root of a negative, you know, okay, I can actually do this. It doesn't just end there. So for example, if I say x squared equals -1, I can take the square root of both. Now remember, it's always plus or minus. We know that the square root and the squared cancel each other out, so I end up with x equals plus or minus the square root of -1, which is I. So if I know I equals the square root of -1. If I'm trying to simplify the root of -9, I can simplify this as the root of 9 times the root of 1, just like when we've been simplifying before. I know that the root of -1 is just I, so I can say this is I times the root of 9 is just 3. So I know it's just 3I. So if I'm simplifying, or I'm solving 2x squared plus 11 minus 37, if I subtract the 11 to both sides, I get 2x squared equals -48. Divide both sides by 2, I get x squared equals -24. Take the square root of both sides, remember plus or minus. These cancel. So we get x equals plus or minus. Now I know the root of a negative just turns into an I, so pull the I out, and I've got the root of 24. Now remember those perfect square numbers. Can we pull out a perfect square root of 24? I can switch it to the root of 4 times the root of 6, but the root of 4 is really just a 2. So this really becomes plus or minus 2 root 6 times I, because we can take that I out. So let's look at this for a second. We know that I equals the root of -1. So I squared is like saying the root of -1 squared, which is just because these cancel out, the squared and the root, this becomes just -1. And then I cubed, I can say is I squared times I. Well, I know I squared is just -1 times I, so that's just -I. And then I to the 4th can be written as I squared times I squared, which we know is just -1 times -1, that's +1. So we know that if we just have I, that we can replace it with -1, or the root of -1. I squared is just -1, I cubed is -I, and I to the 4th is just 1. So anytime we see I to a power, we know it's just going to cycle through these values, these 4 values of I. Keep your eye on this one right here. So these are the 2 that we were pretty much going to use this chapter. So what's a complex number in standard form? So it's a number where we have 2 parts. We have A plus B I. And what this means is A is just a real number. We call that the real component of a complex number. And B times I is just some coefficient of B times the imaginary number. This is our imaginary component. And together, one part is real, one part's imaginary. We call this complex. Just like our relationship status on social media, when, like when you say, oh, it's complicated, it's because it's not one or the other. And this is the same thing with complex numbers. One part's real, one part's imaginary. So how do we do operations with complex numbers? So with addition, we have one complex number plus another complex number. Pretend like these are just like terms. Because this is adding, we can just take our parentheses off, and we can combine like terms with our other like terms. So we know 8 plus 5 is 13. And negative I plus 4I is like saying negative 1I plus 4 is a positive 3I. And this is in complex standard form, which means we always end with the I. And if we're subtracting, remember there's this minus in front. So remember we distribute the minus to both of these parts. So this is going to be minus 3. And minus a negative is a positive 6I. So once I have that, I can bring down these other, the first complex number without the parentheses. And now we can also combine those like terms. So I know 7 minus 3 gives me 4. And negative 6I plus 6I is just 0I, which that number is just 4. And then the last one, when we multiply, this looks just like when we have two binomials being multiplied. So we're still going to use foiling to distribute this. We go first. 2 times 4 is 8. The outer one looks like 2 times 4i. 2 times 4i is a positive 8i. The I stands for inner. Negative 3i times 4 is negative 12i. And then we've got our last term. So negative 3i times positive 4i gives me a negative 12i squared. Now remember, we've seen this I squared before. Remember, but up top, we know I squared is negative 1. So when I see I squared, I'm going to replace it with negative 1. So I know negative 12 times negative 1 is positive 12. Now I can combine like terms. 8 plus 12 is 20. And 8i minus 12i is negative 4i. And that's our complex number in standard form. That's all we have today. Go ahead and get started on your practice, and we'll go over questions next class.